Okay, now let's look at the stereoselectivity of the epoxide opening in acidic condition. As we saw previously, the reaction starts with protonation of the epoxide. That activates both carbon-oxygen double bond, and then we have addition of the methanol. We saw that the regioselectivity, that is, it's preferable for the methanol to have on the most substituted carbon because there's already a positive charge, and that makes the transition state more stable. So now what we need to look at is what's happening with the stereochemistry. So first thing to notice, there's nothing happening here, no reaction, so that should conserve the stereochemistry. So no change. O pointing toward us, O pointing toward us. In the other case, the methanol adds at the same time as the CO bond is cleaved. That will lead to inversion. So the methanol will now be at the back, O, CH3. And to have a full mechanism, we keep the H, so there's a positive charge. And now the metal group will be at the front. CH3, nutshell. Next step, loss of proton. Obviously, no change of stereochemistry. And that's the product forms. This is shown like that. Okay. As we did for the stereoselectivity in basic condition, let's look at the changes or what remained the same. So in this case, the CO bond here is retained. So that carbon here has retention with respect to the starting material. Why is there retention? There's actually no specific reaction on the carbon of this epoxide. No change, retention. In the other case, there is attack of the carbon. So we see here inversion. The metal group that was at the back is now at the front. Same thing here. So with this, there is inversion. Strangely enough here, the reaction proceeds with SN2. Stereoselectivity, inversion of configuration, although it proceeds with SN1 regioselectivity. So that's going to be repeated in the next video, in the continuation of the video, but that's something to be aware of. You can have reaction that operate on the different regime. Stereoselectivity SN2, that's because the attack happened at the same time then the leaving group is going away. But in terms of regiochemistry, SN1 selectivity. Thank you.